Hello, I'm Chris, this is Gross Models. This is day 19 of 30 Days Lost in Space. Right, everything's wired up the same as it was yesterday. I've just rerun the code section because we need these numbers. As ever, I'll let Alex introduce and show us what we're going to be doing today, and then we'll get back to what I've done.
Incoming transmission once again from Inventor Corp. This is Alex. Today is the day. It is finally the day that you guys are going to get up to the surface and out of the water. Now, I'm personally very excited. I don't know what to expect when you get up there. I haven't actually seen any photos or haven't gotten any transmission information that's useful to tell me what's going to be up there. But at least you're not at the bottom of the ocean, which I would argue is probably better. So what we're going to do today is we're going to finally get those things inflated. We're going to get, using those values we found in the last session, or a couple sessions ago, when you decoded that program. We're going to take those values and we're going to input them now into the finalized system. So this is actually a slightly outdated diagram. I'm going to quickly open up the new one, and that should be this one. Perfect. The plans to get you out of the water. As you can see, we have the following hooked up as it goes here. We have the 7-segment display. Again, hooked up the exact same as last time on pins 5 and 6, and the VCC and ground going to those pins respectively. And this has not changed since the last video. Meaning if you haven't unwired the 7-segment display, you should be good to go. And we can just get straight into the code.
So, the code that they provide us with today is again a little bit off. I shall be making some amendments and adjustments to it to make it work in the way that I think it should. So we're looking at setting up the encoder inputs. Now, because we've already got a CLK, a clock, for the 7-segment LED, we're renaming the one on the encoder clock 2. Now you could obviously call it anything you like, but they've gone with 2, so we'll stick with what they've done. I believe the pins are the correct ones. Yes, the pins are the right way around. We haven't got the switch defined in there because we're not using the switch, the button, today. I assume you could use it for something, but we're not. So that's that. We're including the library for the display, obviously. And then we're creating the display label. Again, we're calling it display. Most of this is the same as we did a few days ago. We're creating an array to turn everything on, an array to turn everything off, and an array to have the word done come up. Then we're doing the same as we did yesterday. We're setting the counter to 0, click, click. Yeah, setting everything up exactly the same as it was before. Setting those as input, we don't need the button input, so we're not doing that. Setting up the serial monitor, so that's okay there. The same as it was before, except it's click 2 because we've renamed it. Clearing the display and setting the brightness to the maximum as we did a few days ago. This is the new bit, the interrupt. I'll come back to that in a moment. The void loop is a combination of the two. We're using the 7-segment to display the counter. Then we're waiting for 50, and then if the counter is 50, we're showing the data. You could show anything you like on there. Basically, we're just saying you've got to that stage, so we'll show everything. Now, the 50 shouldn't be 50. That should be the first number we got from the code, which is 23. So after that, we're just clearing the display, adding 5 to the counter, so it's automatically going to go from 23 to 28, and going through the loop again, basically just so it doesn't hit itself immediately straight away. The second number that we've got on there is 353, and the third number we got from them is 1688, which is quite a high number. I don't know that it needs to be that high, but there we go. This is the numbers that we've got for inflating our air bladder or whatever, so we can rise to the top of the ocean, because we've been underwater now for 19 days and I'm getting sick of it. Right, update encoder. There we go. This is what we're talking about now. The interrupt. Now, as far as I understand it, the idea of an interrupt is once you've put it in here, attach interrupt, then when the thing happens, it will go straight to it, no matter what happens. So if there's a change between 0 and 1, I'm not sure about the pin 2 and 3. I don't know how we told it what that was. I don't remember. I mean, it sets up pin 2 and 3, but obviously the only time it mentioned 2 and 3 is in the comments section, so it doesn't read that. But we've attached the interrupt 0, and then we're going to call the update encoder if it changes, as I understand that. It might be completely wrong, but that seems to be what happens anyway. So the interrupts have been set up. So if there's a change on 0 or 1, but again, I don't know how it knows what 0 and 1 are, but it does. So when they change, it then goes down to this, the void update encoder. So this is basically what we did before. We're reading the current state of 2, and we're just calling it. We're not putting a 2 after that clock there, because we don't need to, because it's just a label we're putting onto it. So we're reading that. If it's not the same, we're going to carry on. If it's different, then it carries on. Now this is the bit that is, again, reversed for whatever reason in the code. So I'm going to change it over. I want it to be positive when you turn it clockwise and negative when you turn it anti-clockwise. For some reason, it's the other way around in the code. Again, I haven't figured out exactly what is what for that, but there we go. Then we're printing the direction and the counter on the serial output as well. And then we're changing last state to the current state again, so the loop will actually work. So that should be that. Let me make sure I've got the serial up and running. I'll update that to the file. Let's go to the serial and bench view. Let's compile that, upload that. That is uploading and done uploading. So we've got a 0 showing on there, which is correct because that's, in position 0. If I turn it anti-clockwise, it should go to a negative number. Yep, there we go. -1, and you can see on the serial up top here, counterclockwise, -1, 2, 3, and the numbers there is exactly the same as the number we've got on there. So if I turn this around until we get to the number that we programmed, which was 23, 22, 23. We've achieved that. We're waiting there for it to clear, so we don't get the bend. So our bodies adjust to the new altitude that we're at, and then we continue up. Now I need to go up to, what was it, 353, wasn't it? So again, a silly big number. And if you turn this too quickly, it sometimes doesn't count through. That seems to be better than it was, actually. It's always going. Oh, there's a couple of counterclockwise popping in there, you see, on the serial monitor, although you can't see it on the display. There we go. What I'm going to do this time is try and go past it quite quickly. So I'm going to get to 351 and then go quick. But even going quick, the computer's quicker than I am. So it's added 5 to that. So then we need to keep going until we get to 1688, which, as I say, is a massive number. But that's the number we need, otherwise we're not going to get to the surface, and I want to get to the surface because this recycled air that I've been breathing for the past 19 days is getting a bit ripe. So we'll keep going through there. We've only got another 1,000 to go. So if I keep going and keep going, I can do basically pretty much 10-ish, depending on how quick I go and what it counts and goes backwards 1 instead of going forward. But we're more than halfway there, so we'll just keep going. There we go, the 4th segment has kicked in at 1,000. Yeah, I don't know why that code is different for going clockwise and anti-clockwise. I can only assume that, so there's a setting that can be changed, but I haven't played around with that. 1340. So keep going, nearly there. Now, this obviously you couldn't do with a potentiometer because we're just turning in one direction. 415, there we go, getting there. Only a little bit more to go, and then we can be on the surface and open the hatch and breathe in properly. There you go, 2, 3, 40, 50, 60, 70. Oh, there you go, it went down again. We're obviously getting buoyed by the currents. 3, 4, 5, 6, 5, 6, 7. Done. That's it. We're on the surface. We can open the hatch and breathe a breath of fresh air at last. So that was that. Tomorrow is a test day, and then we'll start a new week. Next week, obviously, we'll probably be removing all of this and starting afresh with different things. I think we're getting the proper screen, not the 7-segment. We're getting an actual OLED LCD screen. So that'll be interesting and obviously much more complicated. But thank you for watching. I'll let the exit play out, and I'll see you tomorrow where I can see if I can get the questions right again. Thanks for watching. Bye bye.
I am really, really looking forward to seeing you guys finally on the surface. Once that happens, I hope that transmissions will hopefully be a little bit easier to go through. And as well, we won't have very much left to do since the ship has been pretty close to being done up and running. We can get you guys home nice and safely in the near future. So it's a celebratory thing for when you finally get to the surface of the water and hopefully to dry land. I don't know how far away the land is, but hopefully it's nearby. As soon as you get there, it's a little celebratory thing we're taking tomorrow to give you a nice sort of a breather, but also a really, hopefully it'll be a fun, interesting challenge that day. So you get to look forward to that. And then we'll focus coming the following days afterwards. We will be getting everything else that's necessary done to get you guys home safely. And I look forward to that as soon as it happens. This has been Alex, and I'm out. Thank you very much.